We continue with solving equations involving surds as we look at quadratic equations producing surd solutions. Most of the times, many times when we solve quadratic equations, we get to encounter surds in our solutions. Like that literally happened in the last video. The last question I answered, we had quadratic equation showing up in the solution right there. So that happens a lot. So this is our opportunity to look at it in from the angle of surd now. So surd solutions, quadratic equations sometimes produce answers that cannot be written as terminating or repeating decimals. Instead, the solutions involve square roots that cannot be simplified to integers. These are called surd solutions. So a surd is an irrational root written exactly using the square root. Examples of surds include square root of 2, square root of 5, square root of 13. Anyone you can simplify is not a surd, like square root of 4 is not a surd because square root of 4 can be expressed as an integer like 4, as a square root of 4 is 2, right? So example of quadratic equation will be something like x squared minus 2 equals 0. If you solve this, you get x to be equal to plus or minus square root of 2. Since root 2 is irrational, the solutions are surds, basically. So now the question is, when quadratics when quadratics produce surds, in what situations do quadratics produce surds? So a quadratic equation has a general form ax squared plus bx plus c equals 0. And as a result of that, we have a discriminant. The discriminant part called d equals b squared minus 4ac. Well, in case you're wondering what the discriminant is, if you remember uh the formula, if you have ax squared plus bx plus c equals 0. So using completing the square method, I think I should, okay, maybe this is the right time to talk about completing the square, right? Should I do that? Okay, let's try to complete the square here. So to complete the square, right? The square, to complete the square, or the first thing we do, we divide through by a. So divide through by the coefficient of x squared, which is a. So we have x squared plus b over ax plus c over a plus 0 over a, which is 0. Okay. Next thing, we we subtract minus ca. So subtract c over a from both sides, from both sides, or you transfer c over a to the other side. That's another way to look at it. So we have x squared plus b over ax equals minus c over a. Then having done that, we can then complete the square. So complete the square. And the way to complete the square is to this is how to complete the square. So you have x squared plus b over a x. Now this b over a now is very important. That's the coefficient of x. So you're going to add half of it. So you multiply it by half. So you have that b over a and you square it. And since this expression is equal to this expression, right? So if you add this one to uh, x plus b over a, then you should add it to the other side. So you have minus c over a again, plus half times b over a all squared. Okay? So now you have x squared plus b over a x plus b squared. If you square this now, that's b squared over 4a squared, right? Yeah, equals minus c over a plus b squared over 4a squared, you know. So you then tidy up. So generally speaking, once you have this, it should actually be the same thing as this expression here should be x plus b over 2a raised to power 2. B over 2a being this expression we have. If you multiply that out, you have b over 2a. So that's what that gives. So, so x plus b over 2, because if you expand, you have x squared plus 2 times x times b over 2a. So 2 cancels 2, right? So you have b over a multiplied by x. And if you square b over 2a, you get b squared over 4a squared. On the right-hand side, now the LCM is 4a squared. So a in 4a squared is a in 4a squared is 4a. So 4a times c, you have minus 4ac plus 4a squared and 4a squared. That's 1 times b squared, that's b squared. So you have x plus b over 2a all squared equals b squared minus 4ac all over 4a squared. That's just to tidy things up, right? So you can then square both sides, because, I mean, take the square root of both sides because we are looking for x at the end of the day. So we take square root of both sides, take the square root, take the square root of both sides. Take the square root of both sides, you have x plus b over 2a squared. Take the square root. So square root cancels square, just like square cancels square root. So we take the square root of b squared minus 4ac all over 4a squared, right? So now we have x plus b over 2a equals, this is square root of b squared minus 4ac all over square root of 4a squared. At least that's one thing we learned from surd, that the square root of, just as a reminder, the square root of a over b is equal to square root of a all over square root of b. So we know that much. So we then go ahead and have x plus b over 2a equals square root of b squared minus 4ac, okay, all over square root of 4a squared. 4a squared, that's 2a. And then we can have x now to be equal to, so you can subtract minus b over 2a from both sides. So we have minus b over 2a plus, now this is square root, right? So it has to be plus or minus. So we have plus or minus square root of b squared minus 4ac all over 2a. Maybe I should even start with this plus or minus thing since mainly the square root is introduced. So I think it's better to just introduce it from there. Okay. So this is the procedure called completing the square method. And then the LCM here is 2a. So 2a into a1, that's minus b, plus or minus square root of 2a into a, that's 1. So minus b squared, b squared, square root of b squared minus 4ac. Now, so the completing the square method has led us to what is called the formula method for quadratic expressions, right? So now you discover, because we are taking square root here, this particular portion needs to obey certain conditions for it to be able to give you because we're taking square root, right? So that's why we now call that part the discriminant. So the part under the square root, the part under the square roots, that is b squared minus 4ac, all right, is called the discriminant. It's called the discriminant. Okay? So we consider as d equals b squared minus 4ac. And this determines so many things. So for instance, it has to be positive for you to be able to get a meaningful answer out of that. If it is 0, you get equal roots. So let's come back here. So that's how we arrive at this d equals b squared minus 4ac. So I had to go through that so you can understand that we didn't just jump at this. So the discriminant determines the types of solutions, like I said. So types of solutions now, if the discriminant b squared minus 4ac is greater than 0, there are two real solutions, right? If d is equal to 0, that is b squared is equal to 4ac, that means that there's one repeated solution. Like when you have x squared plus 4x plus 4, you have two solutions, x equals 2 in each case, right? Yeah, repeated. Then if d is less than 0, solutions are complex, because if this is negative, that means that you're going to get complex solutions. So surds only occur when d is greater than 0, but d is not a perfect square. So you can only have a surd solution when the discriminant is positive and it is not a perfect square. If the discriminant is positive and it's a perfect square, then you are not going to have a surd. You're going to have a rational solution. Okay, so that goes. So we come for the example to buttress that point. You have you want to compute the x squared is minus 5x plus 3 equal x squared minus 5x plus 3 equals 0. So if you compute the discriminant now, d is b squared minus 4ac. So b is the coefficient of x, that's minus 5 squared minus 4. A is 1, then c is 3. So d now is minus 5 squared, that's 25 minus 4 times 1 times 3, which is 12. So d is 13. So you see that this d is 13 now. It is greater positive, and it is not a perfect square. So since 13 is a perfect square, the solutions will contain root 13, and therefore be surd solutions. So this is not a solution to the problem actually, but this is just telling us that we are going to have this radical root 13 in this solution there. Okay, now we come to completing the square, which that is what I've done already, just to show that part I just showed. So completing the square, we write a quadratic as a perfect square expression. So you start with x squared plus bx plus c equals 0, and you move the constant x squared plus bx equals minus c. Then add the square of the half of the coefficient, which is b over 2. You know, in my case, I used b over a. That's why it would have been, it was b over 2a for me. So it's the same process I went through. This is what is called completing the square. Everything I did here. So you have the original. This is the general form now because we have a as a coefficient of x. So you divide through by a, and then you move c over a to the other side like this. Then next you complete the square by taking half of the coefficient of x and squaring it and add that to both sides, and that's how we arrive at this now. So if so in that other case now, if a was 1, right? If a was 1, so you just have minus b plus or minus square root of b squared minus 4c over 2. But this is a more general form that a is not 1. If in case a is not 1, this is what you use. So that's the completing the square I've done there already. Okay, so example 1 now, completing the square. So you have x squared plus 6x plus 2 equals 0. So you move the constant. So it moves constant, which is minus 2. So you have x squared plus 6x. So half of 6 is 3. So you have 6 over 2 equals 3. And then if you square it, that's 9. So add 9 to both sides. You have x squared plus 6x plus 9, then minus 2 plus 9. So that means you have x plus 3 raised to power 2. Because this side now, just like I said the other time, x plus 6x plus 3 squared. So that 3 squared now, x plus 3 all squared is going to give you this expression. And then minus 2 plus 9 is 7. Then you can take the square. So this is now yeah, solving. Okay, not radical this time around. So you're solving this, something with square. So you take square root of both sides. So if you take square root cancels square. So you have x plus 3 equals plus or minus root 7. And then x is minus 3 plus or minus root 7. So these are exact surd solutions in this case using completing the square method. And then we can have a second example. You have x squared minus 4x plus 1 equals 0. So move the constant, which is plus 1, to the other side. You have x squared minus 4x equals minus 1. Another way you can say that is subtract 1 from both sides, right? So you have x squared minus 4x equals minus 1. Then half of minus 4 now, which is coefficient of x, is minus 2. Then if you square that, you have minus 2 squared. Now that is 4. So, and that means you have x squared minus 4x plus 4 equals minus 1 here plus 4. So so this x squared minus 4x plus 4 now is the same thing as x minus 2 squared. So that x minus these 2 squared equals 3. So you can then take the square root of both sides. So you have x minus 2 equals plus or minus root 3 from here. So x is now 2 plus or minus square root of 3. So, and then this takes us to the idea of the quadratic formula. So like I said already, the completing the square method ends up with the quadratic formula. So the quadratic formula solves any quadratic equation for ax squared plus bx plus c equals 0. The solutions are x equals minus b plus or minus square root of b squared minus 4ac over 2a. And that's exactly what I derived here using completing the square method on the general quadratic form, right? So with this now, uh, surds appear when the discriminant b squared minus 4ac is not a perfect square, like we have seen already. So look at example 3 now. Yeah, you have example 3, x squared. You want to solve x squared minus 5x plus 3 equals 0. So you identify the coefficients. First of all, a is 1, that's the coefficient of x squared. B is minus 5, the coefficient of x. C is 3, that's the constant. Then you substitute into the formula. So if you substitute in the formula, you have minus 5 plus or minus square root of minus 5 squared minus 4 times 1 times 3 all over 2 times 1. That'll be 5 plus or minus square root of 25 minus 12 all over 2. So x is 5 plus or minus root 13 all over 2. So since 13 is not a perfect square, the answers contain surds. All right. So these answers contain surds now, like that. Then we have example 4 again. So you want to solve 2x squared plus 3x minus 1 equals 0. Identify values. A equals 2, b equals 3, c equals minus 1 for the formula. So x is minus 3 plus or minus square root of 3 squared minus 4 times 2 times minus 1 all over 2 times 2, because a is 2, right? So you then have minus 3 plus or minus square root of 9. Minus and minus is plus. 4 times 2 times 1 is 8. So 9 plus 8 is 17. So minus 3 plus or minus root 17 all over 4, like that. So from there, we can talk about exact form answers, right? When surds appear, solutions should be written in exact form rather than decimals. Because, of course, sometimes you might be required to do it in decimals. So in that case, you're free. So, but if you want it in exact form, you leave it in terms of the surd. So x equals 5 plus root 13 over 2. Of course, it is equivalent to 4.30, right? But this is a more accurate way to represent it than to have this way. Now you can't trace it back where it's coming from, right? So exact form keeps the solution perfectly precise. Okay. So to simplifying sorts, now of course we've learned about simplifying sorts a lot in previous videos. Sometimes the square root contains a perfect square factor. Example, x is 4 plus or minus square root of 20 over 2. So for the number inside the square root, we know 20 is 4 times 5, which where 4 is a perfect square. So root 20 now is square root of 4 times 5. So root 20 is 2 root 5. So you can now take it back. So you have x equals 4 plus or minus 2 root 5 over 2. And you can factor 2 out so that at the end of the day, you have x equals 2 plus or minus square root of 5. So we have a mixed example altogether. So to solve x squared plus 2x minus 7 equals 0, for instance, if you use the quadratic formula, a is 2, a is 1, b is 2, c is minus 7. So we have minus b, so that's minus 2 plus or minus square root of b squared, that's 2 squared minus 4. A is 1, c is minus 7, all over 2 times 1. So we have minus 2 plus or minus square root, 2 squared is 4 plus, minus and minus is plus, 4 times 7 is 28, all over 2. And then you have minus 2 plus or minus square root of 32, all over 2, like that. So square root of 32 is equal to square root of 16 times 2. So that's 4 root 2. So you can take it back. So you have minus 2 plus or minus 4 roots of 2. So you can factor out 2 also, right? And that 2 cancels this 2 here. So you have minus 1 plus or minus square root 2 root 2. So we can simplify like that. So finally, I come to that point where I get to solve my own problems. Okay, out of questions 1 and 10, so solve each quadratic equation exactly. Leave answers in surd form. So we have questions 1 to 10. Okay, I can't shrink it more than this. So maybe if you just show it in fives, then. So from 1 to 5 and 6 to 10. Okay, I think I want to take 10. 3x squared plus 2x minus 1. 3x squared plus 2x minus 1. Okay, 3x squared. Okay, before I even start solving, right, let me check if anyone requires me to do completing the square. Uh, okay, yeah, no method specified. So let me just do formula method, which is of completing the square leads us there at the end of the day. Or maybe I should do one completing the square and one formula. Okay, so let me do question 2 and then question 10 later. So question 2 is x squared plus 4x plus 2. X squared plus 4x plus 2. Okay. Uh, to solve, to solve x squared plus 4x plus 2 equals 0. All right. Using completing the square method, using completing the square method. Okay. So I have x squared plus 4x plus 2 equals 0. So next thing, I transfer this 2 to the other side. So that means we have x squared plus 4x is equal to minus 2. Next, I complete the square, right? Complete the square. So completing the square means that on the left-hand side, I want to make this a perfect square. So how do we make that the perfect square? So we come and have x squared. So we have x squared plus 4x plus this 4 now. So this 4, we divide it by 2, okay? And we square it. And that is equal to minus 2 plus that 4 again, divided by 2, we square it, right? So, and you take note that this is x squared plus 4x plus 2, positive 2 here. How I wish this was minus. So plus 2. If it was minus, I would have put the minus with it squared. Equals minus 2 plus 2 squared. Okay? So, and this is x squared plus 4x plus 4 equals minus 2 plus, this is 2 squared actually. Yeah. So this is 4 now. So And for this is a perfect square now because we can write it as this x, the coefficient, the variable x, plus 2. That half we got before, all of it squared is now minus 2 plus 4 is 2. So if you see here now, if you expand this, you know, x squared, 2 times x times 2, that's 4x. 2 squared is 4. So we can then solve this. So this is power, we need x, so we can take square root of both sides. So take square root of both sides, take square roots of both sides. So we have x plus 2 squared, take square roots, equals square root of 2. Okay, so square root cancels roots. So square cancels square roots. So we have x plus 2 equals root 2. And then this means that x is equal to minus 2 plus, of course, this should be plus or minus, right? So minus 2 plus or minus root 2. And that is the value of x that we get from that. That's using completing the square method. So let's go back and take 10 that I wanted to take before. Question 10, 3x squared plus 2x minus 1. 3x squared plus 2x minus 1. 3x squared plus 2x minus 1 equals 0. Using the formula method, using the formula method, we know that the formula is written as x equals minus b plus or minus square root of b squared minus 4ac all over 2a. So here we can itemize the values, the value things we need. A is 3. That's the coefficient because this is similar to ax squared plus bx plus c equals 0. Okay, so a is 3. So we have that. Then b is the coefficient of x. So b is the coefficient of x. That's 2 in this case, plus 2. So we take the sign with it, don't forget. And c is a constant. So c is the constant. So the constant here is minus 1. So don't leave the minus behind, because if you do that, you miss the answer. So now we have x is equal to minus 2 plus or minus square root of 2 squared minus 4 into 3 into c. C is minus 1 all over 2 times a, which is 3, so that we then have x equals minus 2 plus or minus square root of 2 squared is 4, minus and minus is plus, 4 times 3 is 12, all over 2 times 3 is 6, right? So we then have x equals minus 2 plus or minus square root of 4 plus 12 is 16, all over 6, so that x is equal to minus 2 plus or minus square root of 16 is 4, all over 6 now. So we have two results. Interestingly, here we don't have a such situation because square root of 16 can be written as an integer or as a rational number. So x now is equal to minus 2 plus 4 all over 6, or minus 2 minus 4 all over 6. So we have x is equal to minus 2 plus 4 all over 6 is 2 over 6, or minus 2 minus 4 over 6, that's minus 6 over 6. So that x now is equal to 1 over 3 or minus 1. So these are the possible solutions of x in this case. Okay, so this does not involve surd as it were. So I take one more question from 11 to 20. From 11 to 20, let me see which one is really can be really difficult here. Okay, let me just take 20 and get going. 7x squared minus 3x minus 2. 7x squared minus 3x minus 2. Okay, 7x squared minus 3x minus 2. So 7x squared minus 3x minus 2 equals 0. So again, using the formula, we know x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So we identify the numbers we need. A is 7, that's coefficient of x squared. B is minus 3, don't leave the minus behind. C is minus 2, don't leave the minus behind again. So x now, so we can then go on, say x is minus, b is minus 3. So don't forget to, minus is in the formula, so b itself has minus. So minus minus 3 plus or minus square root of b squared, that's minus 3 squared minus 4 into 7 into minus 2. all over 2 times 7. Okay, so we then have x equals minus and minus is plus. So you have 3 plus or minus square root of minus 3 squared is 9. Minus and minus is plus. 4 times 7 is 28. 28 times 2 is 56. All over 2 times 7 is 14. Okay, so x is equal to 3 plus or minus 9 plus 56 is 65, I believe. Yeah, that's 65. Okay. Yeah, 65 all over 14. Well, we can leave it this way because we don't have 65 cannot be simplified further. 65 is 13 times 5. We can't extract any square root from that. So at best, x is 3 minus root 65 all over 14, or x plus root 65 all over 14. So if you are told to do it in decimal, then you can go ahead and do that. Maybe use decimals for your calculator. And if not, you leave it in surd form, which is the most accurate form, you know. So with this, I believe we have come to the end of this interesting video about quadratic equations producing surd solutions. Quadratic equations producing surd solutions. So be sure to try your hands on the practice problems. I've done a number of them. I've done 3 out of them. So try your hands on the practice problems, uh, so you can be sure you really get the gist. Thank you so much for listening. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have subscribed already to this channel, I thank you very much for doing that. And if you have not subscribed, what are you waiting for? Go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join. That gives you special privileges like having access to some videos before others, or being the only ones to have access to certain videos as members of the channel. We can also hang out together to discuss whatever interests you on this channel. You can request for PDF copies of my notes as a member of the channel and things like that. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.